Hello there and welcome to a brand new lesson. This is Hap Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at the definition of a function, and by the end of this lesson, you should be able to state the formal definition of a function using precise mathematical language. You should be able to explain the concept of a function as a machine with inputs and outputs. You should be able to define the domain, codomain, range, and then distinguish between the range and then the codomain. You should be able to apply the vertical line test to graphs to determine if they represent functions. And finally, you should be able to identify one-to-one and many-to-one functions from graphs and ordered pairs. Without much ado or say, take your note and your pen so we study together. So let's start by looking at what we call the function machine. Now you can think of a function as a machine. You see, so a machine that we are going to put what? An input in. In this case, we are putting 5 inside this whole machine. You see, and 5 moves through this path. It is processed in here, and then there is what? An output. Now, whatever we have in here becomes the rule or the set of rules the machine follows. You see, so we put in exactly one input and it gives us what? Exactly one output. You see, so we always put in one input. As you can see here, we have put in 5 and it is giving us just one output. This is the function machine. So mathematically, we write function as f, then we put an a, then we say maps to what? B. This is to say that if f is a function from a set A, which we call the domain, it maps it to a set B, which we call the co-domain. You see, so this is how we write it. In other words, we can also write it as f of x is equal to what? A 2x then plus 3, as you saw here in the function. We write it this way to describe the rule. You see, and with this rule, we can solve as the machine has done here, such that if x is equal to 5, then we are going to get what? A 2 into bracket, a 5, then plus 3, which then gives us a what? A 13, as we see over here. So there are terms we need to identify over here. To define a function, formally, we say a function f from set A to B is a rule that assigns to each element of A exactly one element of B. I think for now that is well settled with even this diagram. And as I said, it is written as f, then it maps A to what? B. If we know what a function is, then let's look at the terms that we'll be using along the way. So the first term is a domain. The domain is simply the set of all allowed inputs, that is the x value. Every element of the domain must have an image. That is to say, for our machine we have over here, the elements that would go through the machine is what we call the what? The domain. They are those that are only allowed to go through our machine. And so far as you go through the machine, you always need an output. The codomain, on the other hand, would be what? The set of all possible output. So it is another set that will actually have all possible output that the domain can be matched to. It doesn't necessarily mean that every element in the codomain is mapped or affected by the domain. On the other hand, those that are in the codomain that are actually traced from the domain is what we call the range. So the range are the images of the domain. So I'll draw these ones so that you actually see what we mean. But then, as we are saying, the range is just a subset of the codomain. So if we look at what we have over here, we can say for our domain, we have all of this here being part of the domain. So that is to say, A is in the domain, B is in the domain, C, S, D, S, and then E as well. They are all in the domain. On the other hand, we have what? Our codomain. So everything here in this set is in the codomain. So F, J, H, I, J, K, and then L are all part of the codomain. But you see that there are those in blue which are actually traced from what? Our domain. They are targets from the domain. On the other hand, F and J are not mapped to any element in the domain. These ones that have targets, they are what we call the range. So out of the codomain, J, H, I, K, and then L are what we call the range of these functions. I hope that makes sense. Now, before we start solving some questions, there is one last thing we need to know. On a graph, there is a way we can determine whether or not a function, or let's say a curve, is a function or not. So I'm coming to draw two curves over here, so we use for the test. So the vertical test line says that if we have a graph, you see, and it is possible for us to draw a vertical line that is going to touch two places on the curve, then it simply means that curve is actually not a what? A function. So to prove that test, if we are to draw vertical lines, this is a vertical line. There is no vertical line that when I draw it is going to touch two places on this blue line, which actually represents a curve or a function. But for this one, if I'm to draw a vertical line, it touches at least two places on the curve. That is to say that for this first one, the x value corresponds to just one y value. And that is a one-to-one function. You get it? But for this one, the x value here is corresponding to what? A y value over here. And it is also corresponding to another y value over here. That makes one value of x have what? Two values of y. That is a one to many. You see? So this is what we call the vertical line test, VLT. If you are able to represent your function on a graph and you want to determine whether or not it is what? A function. It is truly a function. This is what we do. With all these tools in place and then understanding intact, let's solve 5 questions to enhance our understanding. So looking at our first question here, it says for f, which has a domain 1, 2, 3, and 4, which maps to z, defined by f of x equals 3x minus 2, we have to find the range. You see, we have to find the elements in the codomain that are mapped by what? These domains over here. So how do we go about it? This is just a matter of simple substitution. We know our function f of x is given by a 3x then minus 2. So what we are going to do is we are going to substitute the x one after the other. See, So starting with 1, we have f of 1, which will then be 3 into bracket 1, then minus 2. No, 3 into bracket 1 gives us what? 3, then minus 2. And that gives us a 1. Then we work also for f of 2. So we are substituting x for what? 2. And 3 times 2 gives us what? A 6. Then minus 2, which in turn gives us a 4. And we solve for f of 3. And that is going to be a 3 into bracket 3, then minus 2. 3 times 3 gives us a 9. So we have 9 minus 2. This one simplified gives us a 7. Then our final one, which is f of 4. That is going to be a 3 into bracket 4 minus 2. 3 times 4 gives us a 12. So we have 12 minus 2, which also gives us what? A 10. They would say, therefore, the range. Therefore, our range is what? The 1, 4, 7, and 10. And we were told that the codomain is the set of integers. But out of the codomain, it is only these 4 values that were produced. As simple as that. So this is how we find the range. Let's look at our second question. Our next question says, does the graph of y equals 2x plus 5 represent a function? You apply the vertical line test and then explain. So we need this graph. Though it hasn't been drawn here, we can draw it ourselves. So we know it is given by y equals 2x plus 5. So all I'm going to do is I'm going to take 2 points so that I'll get a rough sketch of the graph. For x equals negative 2, I have a y equals 2 into brackets negative 2, then plus 5. 2 times negative 2 gives us a negative 4, so we have negative 4 plus 5. This one simplified gives us a 1. Then at x equals 2, we also have a y into bracket y equals 2 into bracket a 2, then plus 5. 2 times 2 gives us a 4, so we have 4 plus 5. This one evaluated, we have what? A 9. So with these points, let me try and then get our graph. So over here, I'm going to plot my graph. At x equals negative 2, we have y being what? 1. So x equals negative 2, y is 1. This is the point. And it is a straight line. A straight line that moves to what? X equals 2, y equals 9. So that is going to be somewhere around here. This is it. So x equals negative 2, y equals 1, and then x equals 2, y equals 9. Now let's look at this line here. You realize that it's a straight line. And for all straight lines, for that matter, for all linear graphs, there is only one line, one vertical straight line that can pass through it. What I mean is a vertical line doesn't pass through 2 points. You see, if you want, we can even try that. So it doesn't matter how I draw my vertical line, so far as it is really a vertical line, it's never going to cut 2 places on this line we have drawn here. And that is just how we determine with a graph using the vertical line test. So our conclusion is simple. We'll say that yes, it passes the vertical line test. Not only does it pass, but then it is even a one-to-one function as well. For our third question, what do we have? It says f is defined on R by f of x equals x squared plus 1. We have to state the codomain of this function. Secondly, we have to find the range. And then C says is f 1 to 1 or many to 1. We have to justify. If you look at the question, the codomain has been stated clearly. It says it is defined on R. So the possible set through which we can get, or in which we can get our range, is what? The R. That is all real numbers. That is the codomain, and that's even been given in the question. So the solution to our first answer, that is A, is what? R, which is all real numbers. Now for the range, we can't list out every element in this function. You see, so we have f of x, which is equal to x squared plus 1. If we wanted the range, x can start from 1, 2, 3, 4, and it goes on and on to infinity. So the range would also continue to infinity, but we can describe it. You see, now we know that for every x squared, it is what's greater than or equal to 0. So if x was even to be negative, you would still get what? The value of x squared being 0. So that would simply imply that our x squared plus 1 is also greater than or equal to what? 1. Because if it is possible that x squared is greater than or equal to 0, then if x squared is equal to 0, that is if x equals 0, then x squared plus 1 will be equal to 1. Hence, for any other subsequent value, x squared plus 1 is greater than or equal to what? 1. This is all we need. It simply means that our range of values would start from 1 and then it will end at infinity. It actually has no end. So it is 1 inclusive and then what? Ends at infinity. That is all real numbers greater than 1 or equal to 1. That is what this means over here. That is going to be our range. C says is f 1 to 1 or many to 1, and we have to justify. Now for this type of question, all you need is to find one proof that it is either 1 to 1 or many to 1. We know the square root of numbers are always positive, whether it being negative or it being positive. So let's just find one of such example that will satisfy that. So for C, let's find f of 2. But first of all, we know f of x is equal to an x squared plus 1. So it simply means f of 2 gives me a 2 squared, then plus 1. 2 squared gives me a 4, then we have a plus 1, which yields what? A 5. Now let's work for f of negative 2. F of negative 2 gives us a negative 2 squared, then plus 1. Negative 2 squared gives us a 4. So 4 plus 1. And 4 plus 1 also gives us a 5. Now with this, you realize that many elements, that is specifically 2 elements, are mapping to 1. So that is simply to imply that f of x is a many to 1 function. And that is all. All we needed was one example. So our conclusion, we can therefore say that our codomain is what? The set of real numbers. And our range is all real numbers greater than or equal to 1. and our function f is a many to 1 for that matter, and it's still a valid function though. Question number 4. This question here says we have to explain why the relation x equals y squared does not define y as a function of x, and what value of x demonstrates this failure. To give you a clear picture as to what to expect, I'll give you the graph of this function so that we know what we are actually arriving at. With the function we are currently working on, this is how it looks like. You see, and I do hope by now you can even tell what type of function it is, and you can also tell whether it satisfies the vertical line test or not. So let's quickly look at a solution. First of all, we can say that if we take any of these values, so if you have to substitute x to be what? 1, you are going to get y being 1, whose squared is also what? 1. And then y being negative 1, whose squared is also 1. You see, they said x is equal to the squared of y. If you have to take x as 4, you are going to get x, that is y being 2, whose squared is also what? 4. And then negative 2 as well, whose squared is also 4. See, so this is to tell you that this function is a many to 1. That is an explanation of why it is not. This relation is a many to 1. That is to explain why this relation is not a function. And it says, what value of x demonstrates this failure? You can take any example at all. And then say for an input such as x equals 4, it gives two values of y. That is y equals 2, as we have seen over here. And then y equals negative 2, as we have seen over here. But how do we present the solution? Let me write that for you. So for our solution, we can say that per our observation, is if x is equal to 4, you've seen the values of y we've gotten. So y squared is equal to 4. And that is to imply that what? Our y gives us a value of positive 2 or negative 2, as we saw on the graph. And this simply implies that what? X equals 4 maps to what? 2 inputs. And hence, it violates the rule of what? A function. We said a function is supposed to be 1 to 1 or many to 1. Now, this is a 1 to many mapping or relation. Hence, it is not a function of x. Now, for the example of an x that demonstrates, once again, we can input x equals 4, which gives us what? These values of y. So that is just it. With all we've done so far, you realize that these questions are more analytical than just solving. It needs you to understand the concept behind these functions before you can even approach a question. Let's look at our last question for this session. So for our last question here, it says a function g is defined by g of x equals the absolute value of x. That is all we need in our function. Now it says we have to find g of negative 5, g of 0, then g of 3. Secondly, we have to determine the range of the function. And then, is g a 1-to-1? If yes, justify with specific counter example and do that as well if it is low. First of all, let me show you how this function looks like on a graph before we actually begin to solve. Now this is how the graph looks like. That is g of x, which is equal to what? Root the absolute value of x. To solve this, you would need to understand first of all what the absolute value function means. You see, so let me use this opportunity to explain that to you. If we have g of x, which is equal to the absolute value of x, the absolute value of x is simply the distance of a number from 0 on the number line. Now, since distance can never be negative, the output of this function is always positive. You see, so that is to say that if you have g of x, it is equal to, so this is how we usually write it, x and then negative x. So if the value of x is greater than 0, we always say that what our answer is x. But then if the value of x is less than 0, you evaluate it as negative x. What does this actually mean? It simply means if we have g of 1, 1 here is what? Greater than or equal to 0. So the absolute value of 1 is what? 1. On the other hand, if we have g of negative 1, then the absolute value of negative 1 is equal to negative 1. Because our x is less than 0, we are going to say a negative the value of x. The value of x over here is negative 1. So negative 1, it gives us what? A 1. This is basically how we define the absolute value function. If it is new to you, you can search on it, then get the understanding. Better still, as we proceed, this is what we'll be using so you'd understand it better. Now that you know how the function looks like from our left hand side and what the absolute value function simply means, let's solve the question. So to help us solve the question, I'm going to leave this function here, which is going to help us. There's a definition of the absolute value function. So for the first one, which is a, it says we should find g of negative 5. So g of negative 5, we say that since our x here is less than 0, that is this, then it simply means our absolute value of negative 5 is what? A negative value of x. And the negative value of x over here is what? Negative 5, which gives us what? A 5. As simple as that. For the second one, we had what? G of 0. That is to say the absolute value of 0. For 0, it is still 0. Then the last one, that is g of 3. For positive numbers, their absolute value are also always what? X. So the absolute value of 3 is simply 3. This is the first part of the question. Now the second part of the question says we should determine the range. We know what the range is. The range is simply the set of all possible output values. That is what the y values can be. In this case, it is what our function can give us. Looking at all we've done here and even the graph, realize that the absolute value can never be equal to 0. You see, it can never be equal to 0. So for our range, we are going to say, let's let our range of values be what? Y. So y is an element of what? R, such that y is always going to be greater than or equal to 0. As simple as that. This is our range of values because the y is always an element of R. right, as noted, and it is always greater than 0. As simple as that. Or if you want to follow how we did the previous one, then we can see the range of value is what? 0 inclusive and then infinity. This is a mathematical way of writing this as well, which is to say that the value of y starts from 0 and has no end. The next part says we should determine whether or not g is 1 to 1. Now we know what makes a function 1 is to 1. See, that is, every element in our domain should uniquely map to 1. You see, but then if we look at how our function has been defined, then over here we have our g of negative 5. If I'm to find g of 5, you realize that it is also going to be an absolute value of what? 5, whose value is also 5. So you would see that negative 5 is giving us an answer of 5, and 5 itself is also giving us an answer of 5. This contradicts the rule of 1 to 1. So it is not 1 to 1, but then many values of what? The x are giving us the same. Hence, it is what? A many to 1. And that is our counter example. So in all, we are going to conclude by saying g is a valid function, you see, and it has a range of what? 1 and it has a range from 0 inclusive to infinity. But it is a many to 1, not a 1 to 1 function. Moreover, you would have even been able to determine that it's a function by using our vertical line test. So if you draw a straight line here, you see it touches just 1 point on our graph. So that will be it for this session in terms of answering of questions. As usual, I'll leave with some exercises so you try on your own just to test your understanding. So we have 5 questions here. We have to try our hands on. You can pause the video and attempt before moving on. Let's have beyond numbers where we learn maths the easy way. I do hope this lesson was helpful. If this is your first time on this channel, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.